A toy rocket with a total mass of 275 grams has an upward acceleration of 48.37 meters per second squared. What is the magnitude of the thrust force on the toy rocket? Now, it would be tempting to look at this and say, hey, I'm given mass, I'm given acceleration, I'm asked for force. Why don't we just do F equals ma and just multiply those two numbers and see if it gets the correct answer? But it turns out that wouldn't quite get the whole story correct. So let me kind of do this a little more following the methods that we've been looking at in this chapter. So I'm going to draw kind of a picture of a toy rocket here. I'm not necessarily that good at drawing pictures. I think I've said that 1,000 times probably already in this class. But this is going to be my attempt at drawing. Here's like a little rocket thruster thing, whatever. I don't know, something like that. But there it is. I'm going to say it's definitely accelerating upward. Okay, that's what it's doing. But now to kind of tell the whole story with forces, I'm going to do a free body diagram and then maybe realize that there's more to the story than I thought that there was, because this is happening on Earth. It's a toy rocket, right? I think it makes sense that it's maybe some kid or maybe under adult supervision set this up to launch in some field or something like that, right? So if it's on Earth, there's going to be the force of gravity. It's going to have to be there. There's also the rocket thruster, right? So there's definitely, I think that it makes sense that would be pushing this rocket, and since a force is a push or a pull, there's got to be that force as well. What do you think? Should that be longer or shorter than force of gravity? I'm going to make it longer because I think for that thrust force to be effective, it needs to overcome the weight force or the gravity force on this rocket. Otherwise, this rocket, instead of accelerating up, would be falling down, and that's not really the goal with a toy rocket like this. So it definitely has to be at least a little bit longer. Maybe I didn't quite have enough space to make it as long as I wanted to make it to reflect that. But that's the free body diagram for this. And now I'm going to write F equals ma. And I like to be kind of formal about this and kind of start with a vector equation, because that reminds me that everything here should include direction. The two forces that are in my free body diagram are the thrust force and the gravity force. They're both vertical forces, so there's nothing really horizontal going on here. So one of the things we've talked about is like anytime you have a vector equation, that you can kind of turn into a component equation. Sometimes there's more than one, but in this case, everything that's interesting is happening vertically. So I think I'm only interested in the y component. So I'm just going to put a y right here and then use this picture to kind of guide me in how I want this to look. And the way I think that this would turn out is I would say, well, the thrust force is definitely up. The gravity force is clearly down. And the acceleration drawn here is also clearly up. So this equation, I think, reflects those directions where minus signs like this one here reflects the fact that one of these happens to be down. I didn't put that in this step because this is a vector equation, and that was kind of included in the definition of f sub g as a vector quantity. But once I went down here, I had to get explicit and say, okay, force of gravity really does point down. Now, again, we're really being asked for this one, right? Let's remind myself before I get too deep into the analysis. That's the question I'm asking. One thing that might help is to recognize we know that the force of gravity is always given by a magnitude of m times g. So plugging that in here is going to help me out a little bit. Then if I add mg to both sides, I wind up getting ma plus mg. And if I had a lot of space and time, I'd say, oh golly, I think I can simplify that by factoring out a common factor of the mass. But instead, you know what? Let's remind ourselves, right? We have a mass of 275 grams. We have an acceleration of 48.37 meters per second squared. So we also know, we're not given this, but we know this, that g is equal to 9.81 meters per second squared. And this is, I'm just kind of checking in here because sometimes it's easy to get a little bit stuck in the analysis and forget what answer you're trying to get to and what information you have and are allowed to use. So at some point, I always like to go back and kind of include those things somewhere just to check, am I really done yet? Have I achieved my goal? And I think my answer is I'm just about there because I have everything I need to plug in here to answer the question of what is the thrust force. The one thing I might want to worry about is the fact that the gram is not the base unit for mass, and maybe convert this to 0.275 kilograms. And then that's the number I'm going to want to put into these calculations here. In other words, this would be 0.275 kilograms times 48.37 meters per second squared. And I'm running a little bit low on space here, so I'll say plus a 0.275 kilograms times 9.81 meters per second squared. And note that that's not as simple as what I originally thought was just to multiply mass times acceleration. I also had this additional term that kind of reflects the weight of the rocket that the thrust is kind of having to push against, and therefore the thrust is going to turn out larger than I would have gotten if I had done it that way. Anyway, these things I can put into my calculator, and I wind up getting a number of like 15.9995, which I think I can just round off to, I don't know how many sig figs we need here, maybe 3. But that rounds off to 16.0, and a kilogram meter per second squared is the definition of the Newton. So 16 newtons is my answer way down in the corner there. I've taken many exams where it turned out like that too. I was running out of space, and then I finally got the answer squeezed in there.